Hey everyone! This video is all about data visualization. Specifically, we will take a quick look into some visualization capabilities in the Wolfram language. The Wolfram language has one of the most extensive visualization capabilities of any language. For a list of all functions used for data visualization, visit this link. As you can see, there are dozens of such functions. In this video, we'll look at charts, list plots, date plots, and last but not least, geographic plots. What visualization function you should use depends on the structure of your data or how you can transform the structure into one that can be fed into one of these functions. Back to our notebook now. Let's start with one of the simplest visualizations, a bar chart. These charts are useful for comparing one single property across different entities. We will try to visualize various entity data with each visualization. In here, let's look at the GDP of Scandinavian countries. We can do that by calling the entity class Scandinavia and calling the GDP property. Plotting it with bar chart gives the following chart. However, we don't know which country is which now. To mark them, we can add the chart labels option and set it to the entity list of the entity class Scandinavia. This is an option, and for the case of visualizations, they're mostly there for stylistic purposes. They're indicated through an arrow. I can enter an option, say chart style, and set it to dark rainbow to obtain a different look on my chart. We see that Sweden is the Scandinavian country with the largest GDP. Next up, let's look at another simple visualization, a pie chart. Pie charts are useful for comparing the percentage makeup of one property by entity. In here, we'll try to visualize the makeup of the solar system in terms of the mass distribution of its planets. To do this, we first need to get all the masses of the entity class planets using entity value, and also indicate we want an entity association such that the pie chart portions are labeled. Plotting the previous output, indicated by the percent symbol, with a pie chart shows us that Jupiter and Saturn make up the overwhelming majority of the solar system planets' total mass. Now let's look at bubble charts. These are useful if you have three-dimensional data but would like a 2D plot instead, perhaps because of a small data set. In here, we'll look at Ivy League universities and their undergraduate-graduate makeup versus their acceptance rate. In order to do this, we will use entity value to obtain the total enrollment, the undergraduate enrollment, and the acceptance rate for all universities in the Ivy League entity class. We will indicate we want our chart labels as the names inside the Ivy League entity class, which gives us this neat visualization in which the size of the bubbles corresponds to the third element, which is the acceptance rate. Now onto a very common type of chart, a box whisker chart. This chart is great for trying to visualize distributions and their quartiles. In here, I wanted to take the entity class particle accelerator and look at the box and whisker summary of its length distribution. And here is the box and whisker summary of this distribution. What if you want a more granular look at the distribution? The distribution chart function is here to help. This function gives you what is known as a violin plot, a very neat way to visualize distribution at a more granular and continuous level. Note that this is the same data as before, but a different visualization of the distribution. Next up, let's touch on list plots. The simplest list plot is a 2D one, which is useful for trying to show correlations between two properties of entities and in general for plotting two properties. In here, I wanted to visualize ocean area versus salinity. I'll make sure to indicate I want an entity association inside my entity value so I have markers on my points. We might need to do more extensive analysis to see if there's a relationship, but the Atlantic Ocean certainly seems to be an outlier. The next function we have is listplot3D, a 3D version of the previous function that also connects points. This function can be really neat for visualizing elevations, both geographically or if you want to substitute in another property instead. We'll apply the GeoElevation data function on a random city, say Pasadena in California. we get the following neat topographic plot of Pasadena. Next up is a list line plot. This is like listplot, but connects consecutive data points with lines. This is useful if you have some ordering to your data, like we do here when we'll be looking at the periodic table and elements. Using this visualization, I wanted to look at the relationship between atomic number and density. Calling the data using entity value is pretty standard. We'll simply use the entity class elements. Then we'll plot this data and we see a periodic trend as expected. Note that we use the grid lines option to place grid lines on the atomic number of noble gases to indicate the end of periods. A similar function is listplot. This is useful for visualizing distributions that are not continuous. It's somewhat like a histogram in appearance, but the data you can enter has to be already tallied and/or normalized. In here, we'll plot the age distribution of the name John. We'll flatten the data to ensure that the unnecessary listing goes away. We see a peak around 60 years old. Next up, we'll look at date plots. These help us visualize data with some sort of date component. The simplest is dateless plot. This is the best function for plotting things like time series. In here, we'll look at the historical data of the United States population growth. To get this data, we'll apply the dated function onto the population growth property and indicate we want all. Of course, this will lie after our entity, the United States. You can see a peak in the 90s. A neat visualization function for less data is the timeline plot function. This will help us visualize events and other occurrences with ease. In here, let's visualize national holidays across different countries. We'll first set up our list of countries, which will include the US, Japan, the UK, and India. Then we'll set up a table that loops through our countries. For each country C, we will use day range to get the holidays for the holiday calendar corresponding to the country C. Finally, plotting this using timeline plot gives us the following visualization. We'll now move on to histograms. These are useful for visualizing discrete distributions. First up, for the normal histogram, let's visualize dinosaur length by taking all such values using entity value. We see that most dinosaurs are under 40 feet in length. We also have histograms for dates. If we want to see which date has had a specific event happen in it many times, we can use date histogram. In here, I looked at the newest 100 elements and their discovery year. The histogram, of course, tallies these dates for us and then plots them. We see a high number of elements discovered in the early and late 19th century. What if you want to visualize a smooth distribution? If you have a lot of values and think a smooth distribution is best, you're better off using a smooth histogram. In here, we'll take the property elevation of all mountains and indicate we want a PDF or probability density function. This gives us the following distribution. Last but not least, we'll touch on geographic visualizations. Our first function is geographics, which can simply give you a geographic plot of a specific location. In this case, we put in a thick black polygon around the Vatican City. We also indicated our georange to be the city of Rome. The second is a geolist plot. It's useful for visualizing distinct points on maps. This is like a list plot, but with geographic coordinates instead. In here, I wanted to look at the position property of all shipwrecks. Note that this is similar to geographics with a geomarker function inside. Next up is the geohistogram. It's like what it sounds, a histogram but on geographic coordinates instead. For this visualization, let's look at the geographic distribution of notable buildings in New York City. We'll first retrieve the entity class of buildings who have the property cities set to New York City. Then we'll use entity value to take all their positions. Finally, we'll plot this using geohistogram, and as expected, we see a concentration in Manhattan. If we want to visualize specific regions or countries and compare their value in one property, a georegion value plot is really helpful. It's like a heat map, but with defined regions instead of hexagons like we saw above. In here, let's set up an entity association using entity value that takes all Middle Eastern countries and gets their population. The entity association is particularly important because if we don't have it, the georegion value plot won't know which data is which. In here, we see a particularly high population in Egypt, Iran, and Turkey. Next up is a geobubble chart. This is also useful for comparing countries or regions in one property geographically. It plots bubbles proportional to the magnitude of the property it is plotting. For this visualization, let's look at countries and the number of nuclear reactors that they have. To do this, we will first retrieve the countries of all nuclear reactors in the data, and then flatten the data and apply the counts function to tally it up. We see that the US has the largest bubble, followed by France and Japan. We already looked at how to visualize elevation in a certain location using listplot 3D. We can also look at elevation using geocontour plot. On the Loch Ness Lake entity, we'll apply geo-elevation data on all geopositions with a certain zoom level from the site, say 10. We can plot this data using geocontour plot, and we see the following contour plot overlaid on the Loch Ness Lake. This neat coloring is due to our two options, contour shading and color function. That was quite a lot to cover. Don't worry, from now on, the videos will become shorter. Now that you have learned the basics, you can move on to real-life explorations, which is exactly what we will do in this course. We're going to cover over a dozen of these explorations, ranging from discovering the most common names to finding out the windiest city in the US. In all our explorations, our two biggest tenets will be entities, which is how we will get most of our data, and data visualization through the functions we just explored. If you ever come into errors, always check the documentation. Oftentimes, it will tell you exactly what you are missing. Treat the documentation of these data visualization functions and other functions like your best friend when learning. I'll see you in the next video, our first chance to apply what we just learned.